So in this class, we'll talk about another statistical test, which is the t-test. So what is a t-test and why do we even perform it anyway in statistics? So a t-test is used to identify or to determine the confidence limit or interval. Let's say, for example, we're performing our titration and we found values. We found 1.2, we found 1.3, we found, let's say, 1.0, we found, say, 0.2, and then we found 1.35, and then we found, let's say, 4.0. So of all these values, at a certain confidence, let's say we want to be 95% confident that our values are okay or they will fall within a certain limit. You want to determine that limit in which the values are going to be able to fall. For example, at 80%, our normal value should fall between this point up to this point. Let's say you are buying something and you want to determine if it is original, right? So at less than 95% confidence, if what you are buying is original, it should fall between, let's say, 1.2 to 1.4. At 95% confidence that what you are buying is original, it should fall between this region. So meaning that if you get something that is beyond 1.4, something less than 1.2, means that that thing is not original, right? So that is the t-test. So the confidence interval or the confidence limit, I can put CI, confidence interval or limit, because we're talking about upper limit and lower limit, is given by first you get the mean plus or minus t. This t is a statistical factor which you are going to find on the t-test table, multiplied by the standard deviation, and then divided by the square root of n being the values that we are dealing with. So to be able to deal with this, let's use an example. Calculate the confidence interval at 95% confidence for the following data. We have 1.25, 1.26, 1.30, 1.31, 1.41, and 1.19. So how do we work out this one? The first thing that we want to do is to determine the mean. The mean is going to be equal to, and you can see I'm using x bar and not mu, because normally in statistics we deal with samples. Mu is for a population. So x bar is going to be the summation of each term, all the terms, divided by how many they are. So we have got 1.25 plus 1.26 plus 1.30 plus 1.31 plus 1.41 plus 1.19 divided by how many are they? 1, 2, 3, 4, 5, 6. So these are 6. And this is going to give us 1.287 if we punch on our calculators, the sum and then divided by 6. Remember, in the formula for confidence interval also had standard deviation. So that's the next thing you want to find. Standard deviation is given by the summation of each term. You remove the mean, you square that, and then divide by n minus 1. Because this is a sample, you divide by n minus 1. If it is a population, you divide by n. So the sum, we have got 1.25. We'll remove the mean, which is 1.287. Square that, plus the next value is 1.26. Remove 1.287. Square also, plus the next is 1.30. Remove 1.287. Square that, plus the next one is 1.31. Remove again 1.287 squared, plus the next one is 1.41. remove 1.287 square, and the last one, how do I write it? Okay, 1.19, we are removing 1.287, and then we are squaring that. We are dividing all these by 6 minus 1, which is a 5, and then we get to square root. If you punch this on your calculator, you should be able to get 0.0739. That is our standard deviation. And make sure that you punch correctly on your calculator, because you might be doing the correct thing, but if you just miss the punching on the calculator, you end up getting something that is not correct. So now that we have calculated the mean and the standard deviation, we can now go back to the formula. And remember the formula that we gave earlier? The confidence interval, or the confidence limit, is given by the mean plus or minus TS divided by the square root of n. So the mean that we have calculated is 1.287 plus or minus. So we need to find t, the statistical factor. We need to go on our t-test table. Remember, we're talking about 95% confidence. How many values do we have? 1, 2, 3, 4, 5, 6. 6 values at 95% confidence. But from those 6 values, get the degrees of freedom. Degrees of freedom is given by n minus 1. So 6 minus 1 is a 5. So we are dealing with 5 at 95% confidence. 95% confidence is equal to 0.05 on the t-test table. So go to 0.05. So you can see where they're intersecting. That's a 2.015. So come here, 2.015 multiplied by S, which is the standard deviation. And the standard deviation we had determined 0.0739, and then divide. Please, this line, the denominator is only going up to 2. Don't let it go beyond to reach to 1.287. Divided by the square root of n, and n is 6. We have got 6 terms. So be 1.287 plus or minus. So if you punch 2.015 times 0.0739 and then divided by square root of 6, you are going to get 0.0608. So this is the confidence interval. If you want, you can as well write it properly. You write the lower limit and the upper limit. So the lower limit get 1.287, remove minus 0.0608, that will give us 1.226. The upper limit is going to be 1.287 plus 0.068608, and that will be 1.3478. So we are 95% confident that our values are going to fall within this limit. And that is it for this class. Thank you so much for watching. Stay blessed. Don't forget to subscribe if you enjoyed this video.